Okay, let's try and unpack this. I mean, 99%. When you hear that 99% of organizations are reporting API security issues, it just stops you in your tracks.
It really does. It's staggering.
That statistic, pulled from industry reports, really hammers home the core question. Why is this so incredibly hard, securing these digital connections that basically underpin everything now?
Well, it speaks to how APIs have changed, doesn't it? They're not just simple interfaces anymore. They're the glue holding everything together. Your phone apps, internal systems, software talking to other software.
Right, like the Stack Overflow guide points out, they are just everywhere.
Absolutely everywhere.
And it's not getting simpler, is it? Today we're diving deep into API security, but specifically looking at, well, microservices, which means way more APIs and this whole new world of AI agents that need to find and talk to each other securely. How do you even start to secure all that?
That's the million-dollar question, isn't it? We're looking at the risks these newer architectures bring and, importantly, the solutions being proposed. We've got a good stack of material for this deep dive.
Yeah, we do.
That industry report, a really detailed presentation from HITB on microservices security, a fascinating paper from Arxiv proposing this agent name service for AI agents, and that practical Stack Overflow guide on REST API basics.
So our mission today is to really sift through all that, pull out the crucial bits. We want you listening in to get a clear picture of the risks and, the best ideas out there for securing APIs, microservices, and these AI agent interactions. Kind of a shortcut through the noise.
Exactly. Finding the actionable insights in all this information.
Couldn't have said it better. Now, before we get into the thick of it, we really want to thank the sponsors who make these deep dives possible. A big thank you to devsahu.vibehack.dev, vibehack.dev, and prompts.cyberagent.exchange. We really appreciate your support.
Yeah.
Okay, so back to that 99% figure. It paints a picture of APIs as like the main doorway for attackers now, wouldn't you say?
Definitely. It's the primary attack surface. And the HITB presentation really makes it clear that moving to microservices, while great for flexibility, massively expands that surface.
Right, because instead of one big application, you've got loads of little ones.
Exactly. Many smaller services, each potentially with its own set of APIs. More endpoints just equals more potential vulnerabilities.
So more doors to lock, basically.
And managing security across all of them gets really complex. That HITD slide 11, I think, it points out the risks, misconfigured settings, maybe weak authentication, insufficient access controls. It's just easier to miss something when it's so distributed.
And it's not just about outside attacks, right? It's also how these services talk to each other internally.
That's a critical point they raise. Insecure service-to-service communication is a huge risk. It can lead to data leakage, man-in-the-middle attacks intercepting internal traffic, or even attackers moving sideways if they breach one service.
Okay, so that's already a complex picture. And now AI agents, autonomous agents needing to find and talk to each other. That sounds like another layer of complexity altogether.
It absolutely is.
Yeah.
The Arxiv paper that introduces the Agent Name Service, or ANS, makes that very clear. Mm-hmm. Our traditional systems like DNS, which helps your browser find websites by name, they just aren't built for this.
Why not? What's missing from something like DNS?
Well, agents need more than just an IP address. They need to know who they're talking to, like verifiably, and they need to know what that other agent can actually do. DNS doesn't really handle verifiable identity or capabilities in a structured, secure way.
Okay. It lacks the trust and context needed for these dynamic AI interactions. You need something more robust for discovery.
Precisely. A way for agents to securely find others based on capability and verify identity before they start chatting.
Got it. So the problem space is clear. APIs are vulnerable. Microservices amplify that. And AI agents add this whole new secure discovery dimension. Let's talk solutions. Where do we begin?
Start with the foundations. The Stack Overflow guide gives a really solid starting point for REST APIs, which are super common. And the absolute baseline, the non-negotiable, TLS, SSL everywhere.
That's the S in HTTPS, right? The little padlock.
Exactly that. It encrypts the data when it's moving. Think of it like sending sensitive info credentials, data in an encrypted envelope. Even if someone intercepts it, they can't read it. And using a certificate from a proper certificate authority proves the server is who it says it is.
And the guide says that's often handled by cloud providers now, or tools like Let's Encrypt make it easier.
Yeah, the barrier to entry for basic encryption is much lower now, which is great news.
Okay, encryption in transit, check. What about knowing who is calling the API and what they should be allowed to do? Authentication and authorization.
The essential pair. Authentication is proving identity, showing your ID card. Authorization is what you're allowed access to once you're inside which doors your ID card opens.
Gotcha. Auth then auth-z.
Right. For users logging in, the Stack Overflow guide points towards OAuth 3, often combined with OpenID Connect. OAuth 2 is primarily for authorization, letting an app access your data on another service with your permission.
Like letting a third-party app access your Google Calendar or something.
Exactly. OpenID Connect then builds on that to handle the authentication part, securely verifying. It's really you logging in, often using accounts you already trust, like Google or Microsoft.
The big advantage there is you, the service provider, don't have to manage passwords.
Precisely. It shifts that risk and makes things like multi-factor authentication much simpler to roll out. Now, for programmatic access, machine-to-machine stuff, API keys are a common approach.
So you generate a unique key for an application, and it uses that key to authenticate its requests.
That's the idea. The guide gives good practical tips. Treat keys like passwords. Only show them once. Make them easy to regenerate if compromised. When a request comes in with a key, you look it up in your database to check it's valid and see who it belongs to.
And then authorization, deciding what that key or user session is allowed to do, that needs to be granular, right?
Absolutely. The guide talks about different levels. Some checks are simple. Does this endpoint need any authentication at all, or is it public? That might happen early in middleware. But more complex logic.
Like, can this user edit this specific document, but not that one?
Exactly. That kind of fine-grained authorization often lives closer to your actual business logic. And the guide wisely suggests using dedicated libraries or tools for this. It mentions OSO as an example, to avoid tangling complex permission checks all through your core code.
Makes sense. Offload the complexity where you can. Okay, shifting back to microservices, that internal communication risk. How do we lock down the chat between services?
The HITB presentation covers this well. One really strong technique is mutual TLS, or MTLS.
Mutual TLS, how's that different from the regular TLS we just talked about?
Good question. Regular TLS is usually one way. The client, like your browser, verifies the server's certificate. With MTLS, it's two-way. The client verifies the server, and the server verifies the client.
Ah, so both services have to prove their identity to each other, like a mutual ID check.
Exactly like that. It builds much stronger trust for service-to-service connections. The presentation also mentions encrypting data at rest using modern algorithms, and maybe using things like VPNs or IPsec tunnels if the network isn't fully trusted. And they point to tools.
Tools to help manage this.
Yeah, service meshes like Istio or Linkerd are mentioned. They can help automate setting up and managing MTLS and other security policies between services.
Okay, MTLS, encryption. What about limiting blast radius if one service is compromised?
That's where network segmentation comes in. The HITB source talks about using things like cloud security groups, Kubernetes network policies, traditional firewalls, basically drawing boundaries between services.
So service A can only talk to service B, but not service C unless explicitly allowed.
Precisely. You contain potential breaches. It's this layered defense, strong authentication, fine-grained authorization, secure communication between services using things like MTLS, and network segmentation. That's the picture the sources paint for microservices.
And, this really loops back to integrating security much earlier, right? Thinking about zero trust principles. It's not just about the runtime, but the whole development life cycle.
Absolutely. Embedding security checks into the DevOps pipeline, the CI/CD process. That's crucial.
Which is where solutions focused on DevSecOps, like those offered by our sponsor, devsecops.vipack.dev, become so valuable. They help automate finding vulnerabilities early, letting developers focus on coding while security is built in, not bolted on.
That shift-left approach is key, especially with the speed of development today. You need security to be part of the flow, not a bottleneck.
Building it in, not adding it later.
That's the goal.
Okay, foundation covered. Let's tackle the really futuristic part, securing these autonomous AI agents. The Archive Papers Agent Name Service, ANS. What's the big idea here?
Right, ANS. It's envisioned as like a universal directory or registry just for AI agents. Think Yellow Pages, but built for secure discovery and trust, way beyond what something like DNS can do for agents.
So it's more than just finding an agent, it's about trusting it.
Trust is fundamental. The paper emphasizes that ANS relies heavily on public key infrastructure, PKI certificates, for verifiable identity.
PKI again, like we use for secure websites with TLS.
Exactly the same underlying tech. Each agent gets a unique crypto key pair and a certificate from a trusted certificate authority, the CA. That certificate is like its digital passport, binding its identity to its public key.
So other agents can use that public key to verify messages actually came from the agent they think they're talking to?
Precisely. They verify digital signatures. The paper lays out the ANS architecture. There is the agent registry itself, the database, the CA issuing certificates, a registration authority or RA to validate agents before they get registered, and this interesting component called the protocol adapter layer.
Protocol adapter layer, what does that do?
It's a clever bit. It allows ANS to handle agents that might use different communication protocols. The paper mentions A2A, MCP. It translates between the internal ANS format and the specific way these different protocols describe agents and their capabilities.
So it helps them find each other and verify identity via ANS.
Right, but importantly, the actual communication after discovery still happens using the agent's native protocols. ANS facilitates the secure handshake, the initial discovery and trust establishment.
Okay, so it's the secure intro service. And how do agents get into this registry?
There's a registration process. An agent sends its metadata and a certificate signing request, CSR, to the registration authority. The RA checks it out, validates it, gets the certificate from the CA, and adds the agent to the registry. There's also a renewal process.
And validation is key throughout this.
Absolutely. PKI is central. But the paper makes a really important point about validation. It's not just the RA checking things at registration. The agent initiating contact is responsible for checking the target agent's credentials every time they interact.
Every single time, a runtime check.
Yes. Verify the signature, check the claim capabilities, match what you need. The RA provides the baseline trust, but ongoing verification is crucial in a dynamic environment.
And they've mentioned some cool ways to verify capabilities. Zero-knowledge proofs. Challenge response.
Yeah, zero-knowledge proofs are fascinating. Proving you have a capability without revealing how you do it, like proving it, password without showing the password. And challenge response is more direct. Give the agent a small task related to its claimed capability, like analyze the sentiment of this sentence to see if it can actually do it.
This whole concept, a secure universal directory for autonomous agents, feels like a really necessary piece if we want this AI ecosystem to be reliable and trustworthy.
It really does. For complex tasks involving multiple agents collaborating, they have to be able to find each other securely and trust who they're dealing with. A framework like ANS is foundational.
It really speaks to the kind of innovation that's bubbling up in the AI agent space. Understanding these emerging capabilities and how they interact securely is crucial, and that ties into the forward-looking work happening at places like vibehack.dev, one of our sponsors, who are really exploring the potential of agent technology.
Definitely. Building this trusted infrastructure is key to unlocking the next waves of AI systems.
Now, the paper didn't just propose ANS, it also did a security analysis using something called the Maestro framework. What kind of threats did they identify?
They looked at several angles. Agent impersonation is a big one, someone trying to fake being a legitimate agent.
And the defense there is the PKI.
Primarily, yes. If you don't have the valid private key and certificate, you can't generate valid signatures, so you can't successfully impersonate a registered agent.
What about messing with the registry itself? Registry poisoning.
That's tackled by having that strict RA validation process, signing the responses from the registry cryptographically so they can't be tampered with undetected and strong database access controls.
Man in the middle, intercepting traffic.
Again, digital signatures provide message authenticity. And ideally, you'd use secure transport like MTLS between the different ANS components themselves.
And just overwhelming the service. Denial of service.
DOS and DDoS are always a concern. The standard mitigations apply. Distributed architecture, rate-limiting, DDoS protection services. But they did note an interesting wrinkle. Similar to potential issues with DNS-SEC, some security features, if not designed carefully, could potentially be abused for amplification attacks in a DOS scenario. So they caution that requires specific countermeasures like careful filtering and any cast routing.
That's a good reminder. Security additions can sometimes have unintended side effects.
Absolutely. You need holistic threat modeling. Another really interesting threat they discussed was side-channel denonymization.
Side-channel denonymization. Okay, break that down.
It's the idea that even just querying the registry might leak information about what the querying agent intends to do. If an agent keeps looking for, say, market analysis agents and then high-frequency trading agents,
you can infer its strategy just from its search history.
Exactly. The queries themselves become a side-channel revealing intent. The paper suggests advanced techniques to mitigate this, like private information retrieval, PIR, where the database doesn't know exactly what was queried, using anonymizing relays, differential privacy, pattern analysis, plus rate limiting and auditing.
Wow, those sound pretty sophisticated, but necessary if agents are doing sensitive work.
For sure. The paper also touches on implementation models, centralized, distributed, or federated registries. Federated, where different organizations run interoperable registries, is powerful but complex, requiring standards and shared trust like mutually recognized CAs.
And beyond the tech, there must be huge governance hurdles.
Oh, absolutely.
Yeah.
Big ones. Naming collisions, who gets superanalysis.agent.megacorp.v1. It's like domain name squatting and disputes. You'd need a governance body, maybe like ICANN for the internet, to manage name allocation disputes, policies for agentized capabilities providers.
And just the scale. Yeah. Potentially billions of agents managing that naming system.
It's a massive challenge administratively and politically. Setting up the rules, managing the trust infrastructure, the CAs and RAs. That governance piece is arguably as hard, maybe harder, than the technical implementation for something like ANS to succeed long term.
This whole area agent capabilities, secure interaction, discovery, it's clearly still evolving rapidly. Understanding what these agents can actually do seems fundamental.
Definitely. And experimenting with how they behave and what they can achieve is key to understanding both the potential and the security needs.
Which brings us neatly to platforms that let you do just that. Exploring different prompts and agent capabilities like you can on prompts.cyberagent.exchange, our sponsor, really helps you get a feel for the building blocks we're talking about, what these agents might actually be used for, and why secure interaction matters.
Hands-on exploration is invaluable for developers and users trying to wrap their heads around this emerging ecosystem.
So let's try and sum up this deep dive. We started with that near universal problem of API security, journeyed through the complexities microservices add, and landed in this pretty cutting-edge space of securing autonomous AI agents with ideas like the agent name service.
And throughout that journey, the core message is the need for robust, layered security. Strong foundations using established practices, TLS, OAuth 2, PKI, leveraging good libraries and frameworks, securing communication channels, especially between services, its defense in depth.
And looking forward to AI agents, the ANS proposal really highlights that secure discovery and verifiable identity are going to be critical. Agents need to trust who they're talking to before they start collaborating.
Yeah, ANS is just a proposal now, but the problems it aims to solve, governance, scalability, robust security analysis, these are the conversations we need to be having to build a trustworthy agent ecosystem.
Absolutely. Because whether you're building these systems, running a business that depends on them, or just, living your life online, understanding how these connections work and how they're secured or not secured, it's just becoming essential for privacy, for safety, for trust.
Couldn't agree more. The integrity of these increasingly complex and autonomous systems is just paramount.
Which kind of leaves us with a final thought to chew on. As these AI agents get more capable, more autonomous, maybe relying on systems like ANS for their digital passports, how do we as a society ensure that the ultimate sources of trust, those CAs, those governance bodies deciding the rules for this new agent layer, how do we ensure they are secure, transparent, and truly accountable to us?
That's a profound question for the future, definitely.
Something to think about. Well, that wraps up this deep dive. Thanks for tuning in.